Today we're going to talk about exponents and multiplication. At the end of the lesson, you should be able to multiply powers with the same base. Before we begin, we want to talk about what a power and a base is. So for example, if you remember, if you have an exponent, the exponent itself is your power, and the bottom number is your base. So what we're looking today is we're going to be multiplying powers or exponents with the same base. So all the bases are going to be the same. In the first example, we have 2 to the third times 2 to the eighth. Now, 2 to the third means that if we take 2 to the third is 2 times 2 times 2. So we're just rewriting that. Then we're going to times that by 2 to the eighth, which is 2 times 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 2. And if I gave you just this problem right here, and I ask you to rewrite that using exponents, you would easily do that by saying that is 2 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2 to the 11th. That's all we're doing. We're just simplifying it. Let's look at the second example. We have 6 squared, so that is nothing more than taking 6 times 6. So we're going to rewrite 6 squared as 6 times 6. Then we're going to multiply that, since it's a product, by 6 to the third. So that's going to be 6 times 6 times 6. If we were to solve that, our base would still be 6. And I have 1, 2, 3, 4, 5 of them, so it would be 6 to the fifth. Now, looking at the next example, I have negative 4 to the 7th. So this is nothing more than rewriting negative 4 7 times. So negative 4 times 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 negative 4. 1, 2, 3, 4, 5, 6, 7. And then I'm going to times that by another negative 4. Now, my bases are all negative 4, so it's going to be negative 4. And then I have 1, 2, 3, 4, 5, 6, 7, 8. Now, the next example shows a product of 3 exponents. I'm going to do it exactly the same way. 3 squared is 3 times 3. So I just rewrote that. Times 3 times 3 squared, which is 3 times 3 times 3. My base stays the same, so I have 3, and then 1, 2, 3, 4, 5, 6. So there's 6 of them. Now, the problem with doing this is what if I have 3 to the thousandths or 3 to the hundredths? I don't want to have to keep writing out 3 times 3 times 3 times 3. So if you notice, if we go back and look, you will see that 2 to the third times 2 to the eighth is 2 to the 11th. And 2 to the 6 to the second and 6 to the third is 6 to the fifth. And if I look how these compare, I will see that the exponents, if I look at my exponents, I will see that 3 and 8, if I add those together, I get 11. And 2 and 3, if I add those together, I get 5. And 7 and 1, if I add those together, I get 8. And 2 and 1 and 3, I get 6. Because this is saying I have 2 3's plus another 3 plus 3 more 3's, and that's 6 total. So the rule is when we multiply numbers or variables, with the same base. That's the key right there. It has to have the same base. Then we do nothing more than add the exponents. So knowing that rule, if you can memorize that rule, if you understand that rule, you will find out that this makes it so much easier. I have the same base, 3 and 3, so all I'm going to do is add my exponents, and I get 3 to the 9th. And if I do that in general terms, I have A and A, so my base is going to be A, and my exponents are going to be added, so it's just M plus N. So if in your notes, I would make sure that you have written in there that when you multiply numbers with the same base, you add the exponents. Now, let's look at this problem. We want to find the area of the rectangle. Well, to find area of a rectangle, it's length times width. So if I look, the length of my rectangle is x squared, and my width is x. And if I multiply them, I have x squared times x. They have the same base, so my base stays the same. And this is x squared, and this is x, so that means there's a 1 there. So 2 plus 1 is 3. So the area is x to the third. And that's all the further we can go, because we don't know what x is. Now, what happens if I have funky exponents? Well, you just break them apart. So negative 3x squared is negative 3 times x squared. And then I'm multiplying that by 5 times x to the fourth. And if you can remember, the associative property of multiplication tells you that you can multiply in any order that you want. So what I'm going to do is I'm going to multiply the numbers first. So when you have something like this where you have numbers and variables, I always multiply the numbers. So I have negative 3 and 5. That gives me negative 15. Then I'm going to multiply the variables. So x squared times x to the fourth is going to be x. And then I have 2 plus 4 is 6. And that's my answer. Remember, we're just simplifying. We're not solving for x. So let's practice these. I have 2a squared, so that's 2 times a squared, times 3a is 3 times a. 2 times 3 is 6, and a squared times a is a to the third. Remembering there's always a 1 there. The next one, this is pretty self-explanatory. My base stays the same, and 10 plus 3 is 13. And then the next problem, I have negative 4y squared is negative 4 times y, to the fifth, times negative 3 times y to the fifth. Multiply your numbers first. Be careful of the negatives. So negative 4 and negative 3 is positive 12. And then y to the fifth times y to the fifth is y to the 10th.